In question number 8, a large number of identical conducting spheres, each of radius r, are arranged as shown in figure. A battery of EMF E is connected as indicated. Switch S1 is closed first. After some time, switch S1 is opened and switch S2 is closed, and similarly so on. The total loss of energy in this process is given by this expression. So find the value of N. So when the switch S1 is closed, at that moment, the potential across the surface of conductor becomes E. So we can write the charge appearing on the conductor is C into V, where the value of C is 4 pi epsilon naught R, that is the capacitance of the conductor, and the value of V is E. So the energy loss in this process is E1. So this E1 can be written as half C into V square, which is also equal to the electrostatic potential energy of the conductor. Now, when the switch S2 is closed and S1 is open simultaneously, then the charge gets distributed between conductor 1 and 2. So in that case, if I write what is the energy loss, then energy loss E12 can be written as initial potential energy, that is Q square by 2C, minus the final potential energy in this system, minus the final potential energy of the system. So the final potential energy can be written as 1 by 2 Q by 2 whole square by C plus 1 by 2 Q by 2 whole square by C, because since the capacity is same of both the conductors, so charge will get equally distributed. So on further solving, the final energy can be written as Q square by 4C. So if I write this is equal to 1 by 4 of Q square by C, or this can be further written as 1 by 4 CV square. Similarly, if I find out what is the energy loss between conductor 2 and 3, then this can be written as, now the initial charge on the conductor 2 is Q by 2. So Q by 2 whole square divided by 2C minus final potential energy of the system can be written as Q by 2 whole square by 4C. So if I solve this, it comes out to be 1 by 4 of 1 by 4 CV square. Similarly, if I find between 3 and 4, then this can be written as Q by 4 whole square by 2C minus Q by 4 whole square by 4C. So on further solving, this can be written as 1 divided by 4 square into 1 by 4 CV square. So now if I calculate the total energy loss in this process, so the total energy loss can be written as half CV square plus 1 by 4 CV square into 1 plus 1 by 4 plus 1 by 4 square, and so on. So if I solve this, it comes out to be 5 by 6 CV square. And if I substitute the value of C and V, then it comes out to be 20 by 6 pi epsilon naught R into E square. So on comparison, the value of N comes out to be 20. So the correct answer for question number 8 is 20. Let's move to question number 9. In question number 9, a satellite of mass m is orbiting around the Earth, whose mass is capital M and radius is r. In a circular orbit of radius 4r, due to friction, it starts losing energy slowly with a constant rate minus dE by dt is equal to eta. The satellite spirals down and reaches the Earth's surface in time t given by this expression. So we have to find out what is the value of k. So let's analyze the situation. Suppose this is the Earth of mass m and radius r, and a particle, a satellite, is initially at this distance, and it is at a distance of 4r from here, let, and it is getting spiral down on this path, and it finally reaches the Earth's surface in time t, let something, this is the trajectory. So since the energy is losing at a constant rate, So we can say that the path of the satellite when it reaches to the surface of Earth becomes circular in nature. So in the initial state, if I calculate what is the total energy of the satellite, then the initial total energy of the satellite is potential energy by 2. So that can be written as 1 by 2 of minus capital G small m capital M by 4R. Similarly, at this moment, if I write what is the final total energy, that is equal to potential energy by 2. So 1 by 2 of minus capital G small m capital M by R. So the net loss in total energy, so the total loss in total energy can be written as initial minus final. So 1 by 2 of minus G small m capital M by 4R plus G small m capital M by R. And this loss energy must be equal to eta into T, because dE by dt is constant. So if I solve this equation, the value of T comes out to be 3 by 8 capital G small m capital M by eta into R. So on comparison, the value of K comes out to be 24. So the correct answer for question number 9 is 24. Let's move to question number 10. In question number 10, a thin convex lens is placed in such a way that its principal axis is along x-axis. So when a small object is placed at minus 20 cm, 1 mm, its image is formed at 25 cm, minus 2 mm. Find the focal length of the lens in centimeter. So it is given, suppose this is a convex lens. So suppose if this is the principal axis, then the position of the object is somewhere here, that is minus 20 centimeter, 1 mm, and its image is at here, that is 25 centimeter, minus 2 mm. So from here we get the magnification as minus 2. Now we know that if this separation is U and this is V, then the ratio V by U is equal to 2. So U plus V must be equal to 45 centimeter, and since V is equal to 2U, so 3U is equal to 45, or U is equal to 15 centimeter. Then the value of V comes out to be 30 centimeter. Now if I apply the lens formula, then 1 upon V, so with sign convention this is 1 by 30 minus 1 by U, so U is minus 15, is equal to 1 by M. So on solving, the value of F comes out to be plus 10 centimeter. So the correct answer for question number 10 is 10. Let's move to question number 11. In question number 11, a uniform and flexible rope of mass 6 kg and length 2 meter is placed on a smooth table with a small part hanging from the edge of table as shown in figure. The rope is released and it starts sliding down from the table. Find the maximum tension developed in the rope in Newton. So let at any time t, the length of this rope is x. So the only gravitational force which is acting on the vertical direction is m by L into x, that is the mass of the hanging part, into g. So this is the gravitational force acting on the chain. So the acceleration of the chain is m by L into x into g divided by total m. So this comes out to be gx by L. So at this moment, if I find out the tension at the different elements, then the maximum tension is at this point. So at this moment, if I write what is the value of tension, the tension at this point can be written as T is equal to mass of this segment. So that is equal to m by L into L minus x into acceleration. So acceleration is gx by L. So on further solving, it comes out to be mg divided by L square into Lx minus x square. So if I differentiate this tension with respect to x in order to get at what point the tension is maximum, so I substitute this equal to 0. So on further solving, we get the value of x is equal to L by 2, and this is the point of maximum. So if I find out the maximum tension on substituting this, it comes out to be mg by 4. So on further solving, the value of m is 6, g is 10 divided by 4. So it comes out to be 15 Newton. So the correct answer for question number 11 is 15. Let's move to question number 12. In question number 12, a square frame made of a thin wire carries current I. The side length of the square is A. The magnetic field due to the loop on the center of the square frame is given by this expression. Find the value of N. So in this case, the magnetic field due to each wire is in the same sense. So the net magnetic field can be written as 4 times into magnetic field at the center due to one wire. So that can be written as mu naught I divided by 4 pi r. So the perpendicular separation is A by 2 into sine theta 1 plus sine theta 2. So if I join the ends of this wire with the center, then this angle comes out to be 45 degree. So I can write sine pi by 4 plus sine pi by 4. So if I solve this, it comes out to be 2 root 2 mu naught I divided by pi a. So on comparison, the value of n comes out to be 0.3. So the correct answer for question number 12 is 0.3. Let's move to question number 13. In question number 13, in the given circuit, the amount of heat produced after the switch S is closed is given by this expression. We have to find the value of n. So let x is the charge given by this battery, then x amount of charge come on this capacitor, then this will move in this direction, x amount of charge will come on this capacitor, x amount of charge will come on this capacitor, x amount of charge will come on this capacitor, and x charge goes back to the battery. So in that case, if I write the KVL, then we will find x by 4 plus x by 3 plus 12 plus x by 6 plus x by 2 minus 12 is equal to 0. So on solving this equation, the value of x comes out to be 0. It means initially the charge on all the capacitors is 0 and the capacitors are neutral. So when the switch S is closed, at that moment let x is the charge, then this charge is distributed at this junction, let y charge goes in this direction and x minus y charge goes in this direction. Further, this x minus y charge comes here and the y charge from here. So in this direction the x charge goes. Now if I write the KVL equation in this loop as well as in this loop, then I can write in the first loop as x by 4 plus x by 2 minus 12 is equal to 0. So the value of x comes out to be 16. So this represents, so x represents charge. And if I write the equation in the second loop, then x minus y by 3 plus 12 plus x minus y by 6 is equal to 0. So on solving this equation, the value of y comes out to be 40. Now the initial energy stored in this system is 0. So if I find out what is the final energy stored, that amount of energy is also dissipated as heat. So the final energy stored is the energy stored in these 4 capacitors. So in this capacitor, the energy stored is half into Q square by C. So x square by C plus in this also. So I can write 1 by 4 plus 1 by 2. Similarly, in these 2 capacitors, I can write half into x minus y whole square 1 by 3 plus 1 by 6. So if I substitute the value of x and y and solve this, it comes out to be 240 microjoule, or I can write in this way 24 into 10 raised to the power minus 5 joule, and this is also the same amount of heat produced. So the value of N is equal to 24. So the correct answer for question number 13 is 24. Let's move to question number 14. In question number 14, a non-conducting ring of mass m and radius r has uniformly distributed charge capital Q. It is placed on a smooth horizontal surface. There exists a uniform magnetic field B in a circular region of radius r, that is r by 4 as shown. When the magnetic field is suddenly switched off, the ring acquires angular velocity given by omega is equal to bq by km. So we have to find the value of k. So we know that line integration of E dot dl is equal to minus d phi by dt. Since the changing magnetic field produces induced electric field, so at a distance r, we can write E into 2 pi r, because at this r the magnitude of electric field is same, and when it is switched off, so when the magnetic field is switched off, the direction of induced EMF is such that it opposes the cause due to which it is being produced. So the E is in this direction, that is equal to minus change in flux divided by dt. So final flux is 0. Initial flux can be written as B into pi into r by 4 whole square divided by delta t. So I can write now the value of E as equal to BR divided by 32 delta t. So at this moment, if I write what is the torque acting on the ring, then the torque acting on the ring can be written as Q, that is the total charge, into E into R, point of application of force. So if I substitute the value of E here, then it comes out to be QR into E, that is BR divided by 32 delta t. We know that tau into delta t is equal to change in angular momentum, that is I into delta omega. So the value of tau into delta t can be written as Q into B into R square divided by 32, and this is equal to I, that is the moment of inertia of ring about axis of rotation. So that is mr square into delta omega, that is omega minus 0. So if I solve this, the value of omega comes out to be QB by 32 m. So on comparison, the value of K comes out to be 32. So the correct answer for question number 14 is 32. Let's move to the first paragraph containing question number 15 and 16.